what did we discuss in the last class? Do you guys remember what did we discuss in the last class? We discussed exception handling, correct? No? Does anybody have any doubt related to exception handling, or what is exception handling? Can anybody answer? We learned about exception handling last class, right? We learned what are the types of exception. Like there is exception class and error class. And what are the types of exception we understood? There are that is checked exceptions and unchecked exceptions. And we understood what is throw statement and throws statement, correct? Then try block, catch block, and finally block. Right? A lot of things we have learned last class. Like, do you guys have any doubts in those topics last class, whatever we learned? If there are no doubts, then I'll wait for another 2 minutes. Let's see if you have any doubts, you put it in the chat window. If there are no doubts, then I'll start with a new topic. Okay. So I'll give it 2 minutes. Just go through whatever we have discussed previously. Maybe any module, you can ask me doubts. In case you don't have any doubts, then we will go with the session plan for today. Okay, I'll wait for another 2 minutes. So just ask your doubts at exactly 11:10. We'll start the class. Okay. I could see no messages in the chat window. So I'm thinking you guys have no doubts. So we'll start with the new topic today. So last class, we learned exception handling. So I told you today, so today we'll be starting with threads concept, right? So this is the agenda for today. We'll be trying and understand what is thread and what is thread API and all this. Okay. So once we are able to finish this, I'm thinking to take up these topics because threads is a very simple topic and we have 2 hours of time. So I will go very slow and try to make you understand all the topics of threads. In case you are able to understand all the topics, and then if time permits, then we go for the other topics. Okay. Otherwise, we will wind up with threads. So that is the plan for today. Okay. Now, the moment somebody says, what is a thread? What comes to your mind? What basically thread means? Or what do you mean by multi-threading? Can anybody give me an answer? Like it can be your own answer. I'm not expecting very relevant answer at all. Like what is this thread, or what do you mean by threading, multi-threading? What do you mean by that term, multi-threading? Any idea? Whatever you know, it's fine if it is right or wrong. What about threading? What do you mean by threading, and what is multi-threading? You can give your own answers. I'll just check the chat window, or you can unmute yourself and tell me. What do you mean by multi-threading? Hello. Yes, you're able to hear me? there any disturbance or anything? No, right? Okay. Can you tell me what do you mean by a thread, or what is multi-threading? Just a knowledge perspective. Yeah. So this is a definition of thread. Having a single flow of execution is called thread. Yeah. I don't want the book definition of it or Google definition of it. I just want you to understand what is a thread generally. Okay. So, like for example, now you are using your mobile application. Maybe you are using chat window in your WhatsApp. Okay, so that chat window and with which person you are chatting, so that person you are having a conversation, right? So that window we can call it as a thread. Okay, so like for example, you have lots of chat history in your WhatsApp, right? Each one of that you can treat it as a separate thread. Okay, and you have an option to upload your profile pic. Maybe that is one thread. Maybe you have an option to upload a status. That is one thread. You can also see how many people are seeing your status. So that is also a thread. Okay, and you can do a video call. That is a thread. Okay, so one application will have multiple threads, and one mobile phone can have any number of apps running. Correct? No, you can play a game also. You can watch a movie also. You can listen to song and then say play some game. All that is possible, right? You mean like multitasking is possible in any application, right? Java is built for multi-threading applications. Means for example, you are using your phone pay. Okay, so how many people are using phone pay at this point of time? There are million people are using the same application at a single point of time. But for everybody, it is working fine or not. Like for example, Teams. Teams is used by millions of people every second, but it is working fine for us also now, right? Means we are one thread in the Teams. So similarly, there will be millions of threads running for an application, right? So if you want to build an application and that application should be enabled with multi-threading, okay? Why it should be enabled with multi-threading? Because multiple users at multiple point of time, they should be able to access your application or use your application. So that is the main intention of going for multi-thread. Understood, right? So running simultaneous things at a single point of time. You are also an example for multi-threaded environment. Means now you are actually listening to the class, and also you are seeing your WhatsApp chat, you are seeing your Facebook chat, or you are seeing Instagram stories. You are doing multitasking. You are doing this also, and you are doing that also. Correct? Maybe you are chatting with your friend saying that I will come to lunch after this much time, right? You will be like you're doing multiple things. You're talking to the person sitting next to you. You're also seeing with your eyes, right? You are a good example for multi-threading. You are doing multiple activities at a given point of time. But if you can consider any computer or a machine, it will have a processor, right? Like a dual core processor, a quad core processor, or whatever Intel processors that you get, right? So what are these processors do? What is the need of having multi-core processors? Because there are multiple threads coming to your application. So to handle that, you need multi-core environment. Okay, multi-core environment. Got this right? Got an idea why should we learn threads? If you are creating threads in Java, it will run on the processor, whatsoever processor that you're having in your machine, and which machine the Java is running. It depends on that. So let us not go too deep into it. Let us understand what are the basics. Okay, what are the basics? Agenda for today, I will understand what is a thread class. Okay, what is thread life cycle? Right? What is the how to implement thread with thread class or runnable interface, right? And you have thread API methods. And these are inter-thread communication methods. You'll understand what is thread synchronization, what is thread interaction. Okay, so these are the main things that we are going to learn. In this, you have thread API and thread methods and their implementations. So these are the basic. Okay, I think somebody has muted my voice. Uh, I'm really sorry if my voice is muted. You're able to hear me now? Okay. Sorry for the inconvenience. Okay. So now I'll just create a normal class. Maybe I will create a class as demo. Okay, what is this demo? Okay, now I'm creating this class and I'm making this class as a thread class. So I will define or will make this class as a thread class. If I want to do that, if I want to make a given class into a thread class, there are two options. Okay, there are two options. One is to make this class, make this demo class child of thread class. What is thread class? This thread class is already present in Java. In java.lang, you already have a class called as thread. Means if you just make your demo class child of thread class, you are able to do multi-threading. Or there is an interface called as runnable. Runnable. So you can implement what you can do. You can go and write a demo implements runnable. If you do any one of this way, if you do any one of this way, you are able to do multi-threading. Okay, what is how to do multi-threading? There are two ways. One is using thread class. You can extend a thread class, or you go and implement runnable interface. Runnable interface. Now what I will do, first I will go with thread class, then I will go with runnable interface. Okay. So what I will do, I will define, I will just remove these two lines. It's just a commented one. No need if it is there, if it is not there, it doesn't make sense. Okay. So here I will do something called as extends right? Thread class. The moment I do extends thread class, all the methods present in the thread class belongs to your demo class. Okay, all the methods which are present in thread class is now belong to your demo class. Okay, and there is one special method called as run method. Okay, run method in thread class. You can say public, or you can write at override. At override means you are trying to override already one method is present in thread class. You are overriding that method. So how do you do? You just give the same name with same arguments, right? So here I will just use or call public or run method. So there is something called as run method. Okay. In thread class, there is a method called as run method. Okay. There is a method called as run method. What is this run method? Any multi-threading task you want to perform, you should write its implementation inside this run method. Okay. You want to perform multi-threading. So that multi-threading, any task you want to perform, that task you should write it inside this run method. Now what I will do, I will so my task is just to print numbers from for int I is equal to 0, I less than some 100, or I'll just take 10 because I don't want very big numbers. I plus plus. So what I'm trying to do, the task here is I want to print number from 1 to 10 or 0 to 10. I want to print this. Okay. So this is my task. And I have a thread class extended to demo class. Inside demo class, I am overriding run method. Okay. What is this run method? Run method is a special method present in thread class where you will write your multi-threaded code. Okay. Multi-threaded code. Now, how to perform multi-threading? Now I'll go to main method. I'll create an object of demo class. So how do I create demo? People go on mute. Please be in mute if you are not listening. Okay. So I'm creating an object of demo. So demo d is equal to new demo. Now, the moment I create an object of demo, what happens here? I created an object of thread. Okay. Now I can directly go and run d dot. There is a method called as start. Okay. There is a method called as start. Okay. What happens if you call this method start? So start method will internally call run method present in the demo. Okay. This is called as multi-threading. Okay. Whenever you call start method, right, it will internally call run method. Okay. What does run method do? Inside that multi-threading code is written. Okay. Multi-threaded code is written. Now, if I run it, there is one thread which is printing from 0 to 9. Okay. And you want to know which thread is printing this, right? If you want to know, okay, which thread is printing this, what you can do is you can go here and also say system.out.println, right? System.out.println. Whenever I get an object, right, or whenever I get any instance here, I'll use this dot get name. This will also print thread name. Okay, which thread is executing it? Can you see thread 0 is executing it? Are you able to see this? All these values, thread 0 is executing. Now, it is not multi-threading as of now. It is not multi-threading. Now, multi-threading means I created only one thread. Now I'll create another thread. I'll create another thread. Maybe the thread name is D1. Now I will also start D1 dot start. Now it becomes a multi-threaded, right? Why it is multi-threaded? I am starting 2 times the same resource, right? I created two thread objects, and I'm printing. Now let us see if I run it. Can you see? First, all the thread 0 got executed. All the thread 0 got executed. After that, thread 1 started. But multi-threading means what? Multi-threading means what? Like both of that should happen simultaneously, correct? Simultaneously, both the threads should work. So if you run it multiple times, you can observe that. See, now thread 1 is executing and thread 2 is thread 0 is executing later. Right? If you execute some other, the output will always change. See, thread 1 is there. After that, thread 0. Now thread 0 is there. After that, thread 1. Okay. It keeps on changing. It keeps on changing. There is no guarantee that which thread is executing which method or at what time or who is given first preference. It is not fixed. Okay. Because all of them have an equal priority. Okay. Equal priority. Now, how do you get to know whether it is a thread or not? Okay. Just go to your main method. So I'm saying D and D1 is a thread. Okay, how do I get to know whether they are thread or not? You can just do system.out.println of D, and also you can print another D1. D1. Okay. Now you just see the output window. Here you can see, okay, thread 0 is one thread name and its priority is 5. So here you can see this is thread name, this is thread priority, and this is the main thread which is invoking the new thread. So this is the representation of a thread class. Now you want to give this thread 0 your own name. Okay, you can give your own name. How do you give it? When you are creating a thread, here you can pass name for it. Okay, say when you created a thread, you say its name is Girish thread. Okay, so this is Girish. Maybe here, if it is not taking the arguments, you can do like this. The D dot set name of, you can set the name of that thread. Maybe you can set it to Girish. That is the first thread. And you can also set the name for the other thread. Say D1 dot set name. So what is the name of this thread? Maybe you can take any other name, say Punit. Okay, so what is happening? There are two threads, D1, D and D1, and I've given names also for them. Once I run it, you can see name of the thread is changed. It is Girish, and priority is 5 here. Priority is 5 here. You can see first Girish was executing, then Punit got executed, right? So there is a equal balance. Next time if you are running it, it might change. See, first Punit got executed, right? Punit got sorry, now the same thing. See, sometimes Punit was there, then Girish came, right? Initially, Girish was there, then Punit came. So it is not, there is no guarantee in multi-threading. Okay, like imagine you are copying two files. Which file will happen first? Can you tell me? No, right? Both of them will be in progress. This file also will be getting copied, and the other file also will be getting copied, right? It depends on how many files that you are copying at a single time. Okay, so this is called as thread creation. Okay, thread creation and running the thread. Do you guys have any doubts to create a thread using thread class? So how did I do? I had a demo class. I extended thread class, and in thread you had a method called as run method, right? I have overridden this run method, right? Overridden this run method, and I have given implementation, right? And I have created object of demo objects. Two threads I have created. I have given them name, and I am running them. In this, you guys have any doubt? Can you ask me if you have any doubts? I'll give a pause here. Do you guys have any doubt? Okay, so one doubt I have, so instead of calling start method, can I call a run method directly? Here, I'm calling start method, right? Instead of calling this start method, can I call this run method directly? Can I call this run method directly? Can anybody answer this? Can I call this run method directly instead of calling start method? Can I call run method directly? Is it fine? Any answers? Yeah, it is public. You can directly call it. Okay. So I will go here and I will call instead of start, I will call run method. Call run method. Now, if you run it, you will get the output. You'll get the output. But here you can see always Girish will come first and then Puneet will come. Always. That change will not happen. Will never happen. First, always Girish will print, then Puneet will print. First Girish will print, then Puneet will print. Why? Because this is not at all a thread programming. This is not at all a thread programming. When you call start method will actually go and schedule the thread. You know thread scheduler, right? You have learned it in your engineering classes. You had this round robin technique, thread scheduler in your microprocessors or OS topic. You might have learned this. There is something called as thread scheduler. Thread scheduler is responsible for scheduling the threads according to the priority. Now, if you're calling run method, it's like you're not at all doing multi-threading. It is a waste of doing multi-threading. So it's a very important interview question. Remember, why can you directly call run method? Why are you calling start method? So the moment you call start method will internally register the thread with thread scheduler. Start method will internally register itself to a thread scheduler so that the thread will do multi-threading based on that schedule. See, now it's now Girish and Puneet sequentially, but next run it will change. See, Puneet came in the beginning, then Girish, then Puneet. There is a mixture of outputs, right? So this was not happening before, right? It was not happening before. Why it was not happening before? Because I was calling that run method. Run method is like normally calling some method. Normally you're calling some method and it is running. It is not at all recommended way. If you want to achieve multi-threading, you have to call start method. Start method will go and register itself into a thread scheduler, and start method will internally call run method. Start method will go and call internally run method so that your executions will happen very smooth, very smooth. So this is one way, right? This is one way. Creating a thread class and then doing is one way. Okay. Now what I will do, I'll remove this code. There is another way, right? What is the other way? Using runnable interfaces. Okay. Using runnable interface. So I will create a new class again. I will make it as a demo one. Previously demo class, I used it for, yeah, once Girish and again once Puneet, correct. Sir, how can we get alternate outputs? Okay, it is not possible to get alternate outputs because thread scheduler is responsible for scheduling the threads. The control is not with you. Control is always with the thread scheduler. However, it likes or it schedules, you will get the output like that. So you cannot have one Girish thread and one Puneet thread alternatively. It is not possible. It is not possible. Okay, so now I'm creating demo one. So what is demo one? It is not ordered at all. No way it is ordered. Okay, randomly it can call anything, any way. Only thing is to call it 10 times. Okay, which thread is calling, it is not a matter, but each thread will have 10 times that it will go and execute it. The order is not at all preserved. Any thread can go any point of time. Okay, so now instead of extending thread class in demo one, I will do implements runnable interface. runnable interface. Okay. So what is runnable interface? If you ask me, runnable interface is a functional interface. It's a functional interface and it has only one method in it. It has only one method in it. What is that one method? Run method. Okay. Can you see run method? Okay. Here you can go and write the implementation. What is the implementation? Previously we wrote this implementation, right? The same implementation we will try to use. Control C and I will paste here control. It can be any task. Okay, here you can give anything. I am just giving this because like to get some idea what it is doing, like in a loop it is doing. If you get multiple outputs, you will get an idea. That's why I've written this for loop. You can write any code here. Okay. So here name will not be possible because you don't have a thread class object. You have to create new thread of. After creating thread, then you can use dot name get name. So now I'll just run it. Okay, I have to go to main method. Here I have to create a demo one object. So I create demo one d is equal to new demo one of. Okay. Now I'll call a method d dot right d dot start method. You should not call run method, but here you don't find start method, right? You are not at all finding a start method. Why? Because you are implementing runnable interface. Runnable interface has only one method called run method. So this interface doesn't have any method like start method or anything. So here you should go and create in your in your main, you have to create thread object. So what I will do, I'll create thread t is equal to new thread of new thread of. Okay. Now what happens? Now, okay, demo one is there and I have a run method also there. So to call that run method or call the start method, I need some instance of thread. Otherwise, it is not possible for me to call the start method. So I will go here and use this reference T thread class reference T. Now I will call start method. Start method. Okay, but whether this is correct? No, right? I have to pass. Okay, I'm saying I created a new thread, but which thread type I created, I did not say here, right? So if you go and understand, the thread class has different like different constructors. You can take runnable type of target. Means, so what is demo one? Demo one is a class which implements runnable interface. So I have to pass this D object inside this thread, inside this thread, inside this thread. D object inside this thread. Now, beautifully, this thread scheduling will happen. And here you can see the output. Okay, only thread 1, thread 2, thread 3, thread 4, thread 5. Means why this is happening? Because every time I'm creating a new thread object. Means I'm creating a new thread object. So every time a new object is created, here also I'm creating a new thread every time, right? So that's why it is actually printing every time a new thread object. So this is not what we wanted. So what we can do, we don't want this type of activity to happen. Okay. So now it will print 1 to 9. It's printing 1 to 9, but this is not we want. We want multi-threading to happen. So I'll go to main method. I'll call once again another new object of thread I'll create. This is T1 and I'll start T1 also here. t dot start, t1 dot start. Now, if you run this, see now you are able to get 1, 2, 3, 4, but it is randomly happening, right? You're getting two outputs. Which thread is executing, you're not sure. Why you are not sure which thread is executing? Because in this, you can't say which thread directly, right? Because you don't know which thread is calling this run method, right? Who is calling this run method? You are not aware of, correct? So like if you like you should also know what type of thread has been called. Okay. So what you can do, how do I print the thread name here? Maybe if I can't print it here, where else I can print? I'm checking. Mm, name, name. Not sure. Which thread is executing this? Thread dot current thread of method is there. Thread dot current thread. Wait, I'll just check and tell you which is the exact method to get that, because it's a runnable interface, right? You don't have reference to that thread object directly. So here I'm doing this dot get name like previously, because you had this thread implementation already done. So because it was having a thread every time, right? So you are aware of it. But here what I'm doing, I'm creating a thread object here. And outside this, I'm creating this thread object. So it is not available there. Okay, this dot current thread dot. Okay, I think I can get this current thread dot get name. Yeah, fine. So now you will get to know which thread is running. But here I have not given any names to the thread, right? Previously I gave Puneet and Girish, but now I am not giving any thread name. Maybe I will give it here so that you will get some idea. I will use t dot get name or set name. Set name. You can suggest some two names. I will set that as two names. You can suggest some two names from your friends. Okay, Jayant,
Prabhas. Prabhas.
Madhu, Prabhas. Okay. So here I have T1 dot set name. So here I will also take, I'll take Prabhas. Okay. Now I run this code. Now you can see first Prabhas is taken an account. Maybe it is like you can see what are the threads which are running, right? Yeah. So initially it started with Jayant and it came here till here. Then Pravas started executing. Maybe the next iteration it will change. Okay, Jayant and then Prabhas. Okay, it was sequential. Maybe after many executions or during the execution, it will change. See here, Prabhas and Jayant. It is actually changing. Initially, it was Jayant, then Prabhas, then Jayant, then Prabhas. So it is like it is random in nature. That's what I am trying to show you guys. Did you understand two ways? So this is the first way. A class extends a thread class, and you have overdone run method, and you will call start method, and start method will literally call run method. So here you are implementing runnable interface. Here also what you're doing, you are doing some task, right? You're doing some task, but you are overriding or run method from the implementation. Okay. So this is nothing but multi-threading. What are the two types of creating threads? One is using thread class, and other one using runnable interface. Did you guys understand this? Any doubts here? Hello, any doubts? I hope nobody's answering. I feel I'll take it as no. You understood. Okay. So here there are some life cycles of thread. Okay. So what is life cycle of thread? If you ask me, thread go like if I say what is the life cycle of Giant? Okay. So Jayant was born, right? So initially, like maybe 25 years or 22 years ago, or 21 years ago, or 20 years ago, I don't know when he was born. So when he was born, he will be in a child state or a children phase or a baby phase. After 3 years or 4 years, he will become a child. Like after 16 years, he will become a teenager. After 22 years, he will become an adult, right? After maybe after 30 years, he becomes a man, and after 60 years, he becomes a uh, like senior citizen, right? It like these are the life cycle methods of a or life cycle stages of that particular person, Jayant. Not only Jayant, it is for everybody, right? Every one of us a life cycle means when we are born, when we are teenagers, when we are old, and when we die, right? So similarly, threads also has this thread cycle. Okay, so moment you call this thread T is equal to new thread of, right? So this is one state. This is one state of a thread. Okay, so let us go and see what is the state of the thread here. So I'll go and do T dot and print system dot out dot println. What is the thread state here? Okay, so I will print T dot get thread state. I'll just use get state. Now, if I run it, it will give me one state in capital letters. That is new state. Okay, this is the first state of a thread. Whenever you create a thread, right, it will be in new state. In new state. Okay, whenever it is running, maybe here it is running, right? So here I will go and see what is the thread state. Okay, I'll see what is the thread state at this point of time. So you can just do current thread dot get state. Get state. Now the state of the thread will change. Previously it was new state. Now it will be runnable state. Can you see? It is in runnable state, right? Runnable state. After this for loop, after execution of for loop, again I will go and check what is the thread state. After execution of this, I will go and see what is the thread state. I'll run it. See, again it is runnable only. Again it is in runnable state only. And if I go out of main method, and here if I see what is the state of the thread, okay, here if I see now, if when it comes out of the thread, out of this main method or out of the run method also, its state will be not in runnable. Okay, imagine, sorry, not here, here. Now it has come out of the thread, right? Out of the run method, it has come. It is inside this. Okay, it is in run method. Maybe I'll put it outside. Outside the run method, if it is present, it will give error. See, the thread state also cannot be defined. That it marks as multiple errors in this. Okay, it doesn't know what is this get state method and all that. Okay. So what is that generally? What I'm meaning is thread state will obviously change when thread is stopped. Okay, or there is a method called as wait method, thread dot wait. If you check when it is waiting, if you check what is the state, it will be in suspended state. Okay, so basically thread has a different state. I'll just show you that. Then we can see. Thread state. See, these are the states of the thread. You have new, runnable, blocked, waiting, timed waiting, and terminated. These are the different stages of a thread. Okay. Now we saw new and runnable, correct? No? When you can see blocked, when it will be blocked. Imagine when it will be blocked. Means it is inside one block in an infinite loop. Imagine if it thread is inside a block and it is in infinite loop. Now that thread will become that will go to block state. Okay, it is not at all active. Okay, and there is something called waiting. So here thread will be active, but it will be waiting for some other resource. And there is something called terminated. After execution of all the task, thread state will be terminated. Okay, so like if you are listening to a song, what is the thread state? It is runnable state. It is already, you are already listening to the song. You paused it. You paused the song, right? This Wink music or anywhere, you are pausing the song. Means what? It is going for waiting state. Waiting state. Then you are again starting it back. Again, it will go back to runnable state. If you close the application called Wink, then you are actually terminating the thread. Okay. So these are the stages of your thread or thread states. Very easy. In your interview, they will definitely ask you any one question out of this. So please be aware of it. Okay. So next thing that we have to learn is what are thread API methods? Means thread class is having lot of methods in it. So what is the use of it and why they are used and all that we are going to learn. Okay. So for example, here only you saw some built-in methods, right? So what are those built-in methods that you observed? Like set name method, right? You are setting here. See, in the main method, you are setting the name. T dot set name means for a given thread, you can set the name. Okay, you can set the name. You can also set the priority in which it should execute. So you can use for T, I'm giving highest priority. I can do T dot set priority method. So there is something called set priority method. Here I can set from 1 to 10. 1 means least priority, 10 means highest priority. I can also set the priority of the thread for T. For Jayant, I'm setting maximum priority. Okay. So when you run here, so Jayant will be given first priority. First priority will be given to Jayant when you're running this because it's his priority is high. Okay. So first priority will always be given to Jayant. See, Jayant will be given some more priority compared to Prabhas. So that's why jnth will be always. You can see jnth will never come at the end. Jnth will never come at the end if his priority is high. See, every time Prabhas is coming at the end. Sometimes this person also can come depending on the thread scheduler's capability. Okay, thread scheduler's capability also depends. But most of the time, Prabhas will be at the end, not the jnth. Okay, so that is called as priority method, set priority method. And there is something called as T dot. If you want to say how many threads are running, okay, if you want to get what is the count of threads which are running currently, you can go and say get a count of thread. Okay, so get thread count. So this can be applied here because it's a static method. You can just go here and call that method here only. Control C and Control V. How many active threads are there if you want to know? So you can just use thread dot get active count. Okay, how many threads are active? If you want to understand, then you can go for get active count. Means if everything is number, then it will be very confusing. So instead of that, you can use some other um, thing to print here. Maybe you just print A instead of printing numbers, so that you will get to know what is that count. Okay. Okay. Here for see here you're getting the count actually. How many threads are active? It's a bit confusing because here we have some more values, right? So we'll just remove them. Okay. So now if you run it, you will get to know what is the count. See, 2 and 3. So after A, you are printing 3 means there are 3 threads active. Here it is 3 threads, and here it is only 2 threads are active. So this will give active count. Okay. Similarly, you have lots and lots of method. Okay. You can go and use methods like T dot. Here you can get the ID, get name, get priority, right? Get state, get thread group means you can define a group of threads also. Is alive. This will give true or false. Means if your thread is active or it is in new state or in runnable state, this will be true. Otherwise, it will be false. So is daemon off. Okay, daemon method is nothing but it's a method without name, or we can say daemon is nothing but ghost kind of method. There is a method called join. If you want to join one thread with the other thread, like T1 join T2, if I do, first it will wait until all the T1 gets executed, then T2 will be given preference. Then if you want to do such kind of thing, you can use join method. Say for example, here I have defined T1 and T2, right? So here I will do uh, T1 dot join, right? T1 dot join, or I will do T1 dot join. Sorry, T1 dot join T. So join method has some error. Okay, I'll just remove it. here it is saying it might get some exception, it is saying. So you have to add surrounded by try and catch block. Means there may be some exception. We don't know. Interrupted exception might happen. We don't know. That is the why I am catching that. Now you can see only three will be executed. A will be executed and then B will be executed. Means in case you are here, I'm having A and B only. Here I'm having 1 and 2. If I'm printing this J, you will under I will understand this. Cause and also I need name, thread group name. Just the name of the thread that you'll understand that. We don't want this thread count. We already know what is that thread count. Dot current thread. Dot name. Get name. So this is one method. I'll save it and run it. Now you can see first Jayanth will be executed. After that, Prabhas is joined. So no matter how many times you execute, Jayanth will come first, then followed by Prabhas, or Prabhas will come first, followed by Jayanth. So join method will do that. Like it will join one, it will complete one thread and then join to the up next thread. Okay, but it is again case to case. It is not always one after the other. It might also jumble. Okay, because it's threads, you don't have a control over it. So they choose their own execution path. So they gave their own priorities. So you can't control. You can't have a control over them. Okay, so this is one. So if you, there are lots of methods. If we start discussing, it will never end. So just want to generalize and tell you by using this thread. So you can just go to this thread class. Okay, you can see here lots of methods will be listed. Yeah, so active count, clone, you have current thread off method, destroy method, suspend method, you have dump stack, you have get all stack traces. Lots of methods are there like get ID, get name, get priority, get stack trace, get state. Okay, lots of methods are there when it comes to thread handling. Okay, so not a very important question for coding rounds and all. They'll not ask you any questions in coding round, but face to face thread interviews, whenever you get, right, definitely this will be one question they will ask you on threads. You should have some idea on what are these. Okay, so coming to the next topic of threads, there is something called as inter-thread communication. Before that, you have something called as synchronization. Okay, so very important topic or very frequently asked question in interview. What is thread synchronization? Okay, so people understood there is a problem that there is uneven execution pattern, right? Maybe two threads can occupy one resource at a time, and it will create a problem. Like so, like what is the solution for this? If there are if there are two threads, okay, fine. If there are 1,000 threads, single at one point of time, trying to access that resource, right? It will cause lot of issues. Imagine you and say Jayant and Madhu is trying to book a train ticket. Okay, both of them are trying to book, and there is only one ticket. So what happens? Jayant already booked, but he did not do the payment. But Madhu also booked and he did payment. To but to whom the ticket should go? First, already Jayant booked it, but he did not pay. But Madhu has already booked and paid it. So to whom this ticket should go? There is an ambiguity at the end of the day, right? Always Madhu will be given first preference, then Jayant, because he paid the money in advance. Okay. So these kind of issues, to avoid these kind of issues, they come up with a solution called as synchronization. What is synchronization? One thread will access one resource at a given point of time. Okay. One thread, if it goes to this start method, only one thread will execute until the thread completes. Remaining threads will wait. So it's like you have a public toilet. Everybody is allowed to go to public toilet, but one after the other. One thread, one person should go, complete, come out, then the other person should go. It's not like everybody go and use it at the same time, right? So to make this happen, they introduced a concept called as synchronization. What is synchronization? Like making threads safe. Okay. In real time practical scenarios, how do we achieve it is the question. So if you are seeing thread class here, right? There are two implementations I did. What is this? Okay, so two implementations I did. One is using class. Yeah, so one is using this class implementation and other using the thread, this one runnable interface implementation. So whichever case you can declare one synchronized block, or you can have synchronized method. So synchronized block or method. So using any one of these things, you can have synchronization happening. Okay, there is a keyword called as synchronized. Okay, synchronized is a keyword. You can use that keyword to synchronize. So imagine this is a run method. So whenever you are calling this run method, the resources in this should follow synchronization. So what you can do is in this run method, you can write a synchronized block. Okay, what is synchronized block? You can use synchronized keyword, and here you can use this and write your implementation inside that synchronized block. So I'll just Control X and here Control V. Now I have a synchronized block. Okay, what does the synchronized block will do? Now this synchronized block will allow only one thread at a time. It will not allow multiple threads at a time. Okay, so let us see how it will allow one thread at a time. I'll go to main method and now I'm running this code. So imagine here there is no chance of Jayant coming at last. Okay, so first Jayant will go, finish execution, then only Prabhas is allowed to enter. First only Jayant, then Prabhas. Now it is purely you can see code is synchronized in nature. Means only Prabhas is given first, Jayant is given first entry, then Prabhas. There is no miss and match. How many times you do, it will be the same. Okay, so let us go back and see how it is happening. So we'll go and put a debug point here and see how this is happening. So I'll just debug it. Now, see, now it has actually come from here. It has only entered this and these names are set. And only thing it did, it executed the state of the thread. Where is the state of the thread? This one. Only state of the thread it executed. It is in new state. Now it came here. See, it came inside the synchronized block. What is this says here is, this says which thread it is. See, this is the thread number, which thread it is coming. No, that this is the number of the thread. Only this thread will be there inside this block until this for loop finishes. Okay, see, thread name is Jayant. It is there in this block only, right? Now Jayant. Okay. Every time it is, even though there are multiple threads are not allowed to come inside. this synchronized block. See? Now it is going out and it is printing it. Now it next turn is this Prabhas, who is coming, and for him again the thread is locked, and only Prabhas outputs will be printed. There is no way that there is a miss and match happening. First preference, only first thread which is entering, only Jayant or maybe Prabhas also can go. If Prabhas is going, okay, until Prabhas finishes execution, Jayant will not be given permission. So this is called a synchronized block. Synchronized block. You can make it like this, or you can, it's an option. Okay, you can make it like this, or you can make this method, run method only synchronized. Okay, so you don't want to do like this, then you can go and make this method as synchronized. There is a keyword called as synchronized. Now this entire method, run method, is synchronized in nature. Now also if you are running, you will get the same output. Jayant first and then Prabhas. Are you able to understand what is synchronized block and synchronized method? Did you understand this? Yes or no? Anybody has a doubt in synchronized block and a synchronized method? You're able to make sense of it, right? So what is synchronized block? You can make this entire for loop block as a synchronized block, and any threads, in case there are 4 threads or 5 threads or 1,000 threads, no matter how many threads, one thread is given permission at a time. Not all the threads are given permission at a time. One thread at a time will be given permission to execute this block of code. Okay, so that is called as synchronization. So it can be block level or method level. I can declare it to a method saying that, hey, this run method must be synchronized in nature. Means what? Okay, whenever a thread is entering into this run method itself, it will be synchronized in nature. Means it, if it enters, it will not go out until it finishes that block. So one thread at a time is given permission. If you go to your public toilets and all, right, you have one person going inside and he will lock it, correct? There is a lock. Until he finishes his daily routines, he will not open the lock. Similarly, this block is like that. Once you enter it, you will be locked. Nobody else can enter it. So this is called as synchronization. Okay, synchronization. Now, can you tell me whether this is advantageous or not? How many of you feel it is advantageous or not? Can you give your comments whether it is advantageous? What do you think? Anyone in the chat, can you tell me whether it is advantageous or not? What do you feel? Say yes or no at least, like whether it is advantageous to have synchronized block or it is not advantageous to go with synchronized block. What do you think? Okay, no answers. Can unmute and tell me at least. Okay, somebody says no, somebody says yes. Okay. So actually answer is like that, right? It is both advantageous as well as not advantageous. Why it is advantageous? Because one thread is given permission at a time, so there will not be confusions. Okay, but if it is synchronized, you could have written normal code only. No, why you want multi-threading code? Correct. No, multi-threading means the task should be done parallelly. So it is not advantageous. We feel no, it is not advantageous. Why? Because if you want to make it synchronous, then go with normal program only. Why do you come with multi-threading? Multi-threading is used to execute multiple threads at a single time, right? Multiple threads at a single time. Got it, right? Just a moment. Just a moment. Okay. Sorry, some background noise. Okay, so done. So it is disadvantages also, right? Both advantages as disadvantages. Now, how do we solve this problem? they have come up with inter-thread communication. Okay, so what is inter-thread communication? We need to understand. So that is the last topic for threads to happen. So I'll give one scenario. Maybe if you understand that scenario, you'll understand what is this inter-thread communication. Okay, so what is this scenario is? Just a moment. Somebody has something in the chat window. No. Okay, somebody's leaving the conversation. Somebody is joining the conversation. I don't know why these guys have left the conversation. Okay, there were 45 students in the beginning. Now there are only 35 students. I don't know why they left. Maybe because of some internet issues. Okay, so now, imagine, in case if you wanna perform this multi-thread communication, there are three basic methods that you should remember. What is multi-thread communication? To understand this, you need to understand these three basic methods. Okay, so for that you should understand this example, so it makes a lot of sense for you to get a hang of it. Okay, so like imagine you are going for some giving some order, like imagine your friend's birthday is there, you are going there to give some order for some cake. Okay, you are giving some cake order. So cake order, cake order. Okay, so what is this cake order actually doing? Like where do you give this order? You are giving it in some bakery or cake shop or something, right? Maybe you can take it as some cake shop. You're giving this order. Okay, now when you go and give this order, maybe you are having a picture cake or whatever cake. The moment you go and give an order, what that shop owner will do, he will ask your number, and he will ask you to pay some advance. Pay some advance, right? Advance. Once the cake is ready, he will call you. He will call you, and you should go and pick it up. You should go and pick that cake. So this will be the general way every cake shop works. Correct? No? Have you observed this in your locality? If you want to order some cake, you will go and give an order to the cake shop, and after some time he will ask you to give the number and pay advance. And after some time he'll call you and go and pick the call. Some shops will deliver it to your address. You can give your address and come. He will deliver to the address. Let us understand this scenario. Okay. Now, how many of you are giving order at single point of time? If it is New Year or Christmas, there will be thousands of cake orders that you have already given. Like your friends and lot of people will be giving cake orders to the same shop. Correct? No. Now, how he is going to call everybody? Like he will have one call executive. Whenever cake is ready, he will call that person, and that person will come and pick the cake. Correct? So just take this example and let us try to understand. Now, in inter-thread communication, right? In inter-thread communication, we have a method called as wait method, notify method, and notify all method. Okay. What is wait method? Wait method is at consumer side. Who is the consumer here? Who is the consumer? The one who gave order to the cake, right? He is the consumer. He gives the order, and he will wait. He will wait. Once the order is done, this person will call, right? This is nothing but notify. Notify method. Notify. Will he do only notify, or he will do notify to everybody? Means there are so many cakes prepared at one time, right? So he will give notify all. Correct? He will do notify to everybody. Right? So one method is wait method. Who will be waiting? The person who gave order will be waiting. And there is a method called as notify. Notify means calling that, okay, this you are waiting for some resource. That resource is ready. To tell that, there is a method called as notify. So what does basically notify do? It says, hey, boss, I am done with the cake manufacturing. You can come and collect it. So this is called as notify or notify. Okay. If you closely observe, these methods, notify all and wait method, is present in object class. Okay, what is object class? It is the parentmost class for all the classes. Parentmost class for all the classes. It has no relation with thread. Okay, this has no relation with thread class. So these three methods, notify, wait, notify all, it is present in object class. What do they do? Imagine there are two synchronous blocks. Okay, so imagine the scenario, like uh, imagine there are two situations where there is only one compartment of train. You are trying to book a ticket, and other person in that compartment is wants to cancel the ticket. Okay, so what will happen in this if they are doing simultaneously? So both are synchronized in nature, right? Means only one person can go at a time. If it is ticket booking, making synchronization makes sense because only one person can book a ticket at that point. Others should be blocked ticket ticket booking. So this is synchronized in nature. So like one person is trying to book a ticket and other person is trying to cancel a ticket. So like in this, there is an ambiguity. Okay, one person will keep on waiting until the other person to cancel the ticket, and the other person will keep on waiting for the again another person to uh, have it booked. It's like imagine you ordered something in Swiggy. Okay, and that Swiggy delivery person has come till your location. Okay, till your location he came. What you will be doing? You will be waiting for that Swiggy person to call you, and Swiggy person will be waiting that you will call him because he reached the destination. Because you can see that in the map. So both of you will keep on waiting. So this is called as deadlock. There is a scenario of deadlock. So a Zomato guy will keep on waiting that you will call him, and you will be waiting that after reach he will call me. Right? This situation is called as deadlock. Deadlock. So to avoid this deadlock, you can use this notify all, and wait method. Wait method is like in the customer side. Customer will be waiting for pizza to come or something from Swiggy to come, right? And what does notify should do? When a delivery guy comes to your location, he should give you a call or he should send you a message notifying that I already reached the destination. Can you come down or something like that? He should send you a message. After seeing the message, you will go down and collect that pizza. Correct. When two resources are waiting for each other, so that scenario, like now I told you one scenario, right? So like you want some notification from the user, from the Swiggy guy to go down, and that guy is waiting that okay, you will come down and collect it. So these two are like a scenario in which both are waiting for a n number of time or for a long time. So imagine here you have a resource which is synchronized in nature. I told this is a resource which is synchronized in nature. Now, who should occupy this? Imagine there are two threads which I'm creating. Say here in my main method, I'll just go back to the previous code. Okay, so you have this two threads, T1 and T2. Now both this T1 and T2, Jayant as well as Prabhas is trying to occupy this resource, right? Both are trying to occupy this synchronized block. But I told only one resource at a time can occupy this block at a time, right? So now what happens? There should be, if there is another interthread coming, there is another synchronized block. Imagine there is one another synchronized block, say like this. I'll just copy this run method, and I have another method. Imagine this method is something called not run method, say jump method, some jump method. Okay, some jump method, and here you are in this run method. I'll end this run method here. I'll delete one not have confusion. For loop. Okay. This is run method. Starting here and ending here. Class. Okay. So now what is that I am doing? I have a run class. So there is a run method. This is also synchronized, and you have a jump method. This is also synchronized. Okay. So now from run method, I will call this jump method. From this run method, I will call this jump method. Okay. And this jump method will call run method. Run method. Means, see what is happening. Both of these will be waiting for each other. So run method will be waiting for jump method, and jump method will be waiting for run method to complete. So it is like one resource is waiting for other resource. So this scenario is called as deadlock scenario. So here you will get illegal state exception. Here you will get illegal state exception because both of them are waiting for each other to access the other block. See here. See the output scenarios, how it will be. It's like an infinite loop. It's an infinite loop. Both are waiting for each other for a long time. Okay, so this scenario is called as deadlock scenario. So we'll see that we just go and execute, or we'll do this research and see. Okay, now this is run method, right? Start method. It is calling this run method. See what it is doing. It is printing Jayant. Now it is calling jump method. Every time it is calling this jump method. You can see here. Every time it is also calling this jump method. So we'll go to jump method and see what is happening in jump method. Every time it calls jump method, here you're printing something, and here you are again calling back run method. It is coming to run method. Again, it is calling jump method. Again, it is coming to run method. So this will never end, right? This will never end. This will always keep on happening until some point of time, both of them will be always waiting for each other. It's like it is waiting for this to complete, and again it is waiting for this to complete, and both of them will never complete. Okay, so to avoid these scenarios to happen, we come up with something called as wait. Say for example, here I will just write a method. So this is something called as consumer. Imagine this is a consumer. So after finishing of this method, here I will write something called as wait method. Wait method. So it is object class method. So you can directly use object.wait. Object.wait. Okay. And you have to also say how many milliseconds you are waiting. Maybe you can say 250 milliseconds, something you can see, or you can also use this thread dot current thread of dot wait. So here you can pass some milliseconds. Maybe you can say 2000 milliseconds I am waiting, or 3000 milliseconds I will be waiting. So this will give you a checked exception. So you need to at least throw it or handle it. So I told you that what is the best way is to handle it. So it might give illegal thread state or interrupted exception. So I don't want to throw it. Sorry, don't want to throw it. I want to have try and catch block. So done. So now I'll save it and restart. Now what I'm doing is I'm instead of having it multiple times, I am waiting here. So here I am waiting current state dot wait. So until what I will wait until this completes, I will wait. As soon as this completes, here I have to notify. Okay, so I can do this dot or thread dot current thread dot notify or notify all. I can just use notify because only one person is waiting for me. So after this finishing, right? After this finishing, I'll call notify method. Once I call notify method, it will break this what is synchronized block, and it will come here. It will execute this wait. So because it is waiting for this to complete. Once this completes, it will send a notify, and this action will happen at that right moment. Then you will not have that issue. Paste. Now you have illegal monitor state exception because you are having this jump call here. Just remove here. So just restart. Okay, illegal monitor state exception. When it is happening, you should see exception at thread Jayant and Prabhas. So like now, like one thread, same thread is actually there, and you are trying to do that here as well as here. So that's why you are getting that illegal monitor state exception. Okay, so after completion of this, then you have to call notify method. Maybe I will call it after this. I'll call notify method. Okay. So here it is waiting, and now the notify will be called. You can observe now. Now after finishing this everything, after finishing Jayant's activity, then Jayant will come and call notify that I have finished the execution. Now what will happen? Okay, now Jayant has finished the execution, and who is waiting for that resource, that person will go and catch that resource. Notify he is calling. Now jump method was waiting for this notification here. So there is a wait method which is waiting for this to complete. Okay, maybe after notifying, you can call jump method. Okay, still it is executing Jayant and section in thread. For that, at the last moment, it is giving some illegal state exception because the same thread is being used for both the activities. Maybe that is the reason. So did you understand the idea here, right? Or you understood the concept here, right? So how to avoid deadlock is you call notify method, means after I completed all this, now I will call notify method, and the person who is waiting for notify is this wait method. So the wait method will go back and execute that call or execute that particular code. Okay, so this activity of having wait and notify all, this is called as inter-thread communication. One thread will communicate with the other thread saying that I am available, or I am sending the notification saying that now I am available. You can come and occupy the resource. So that is the overall idea of this. Okay. So I think that is the main concepts that you need to learn here. And just go to thread class and understand thread class implementation, how thread is implemented and all that. So that is very important when it comes to learning point of it, and an interview point of it and all. If MCQ questions are asked on thread, you should know which are the methods present. Okay. Just go and have a look of methods present here and try to solve them. Okay. I think that is all for today. I just wanted to cover some more topics, but I don't want to make it too much clumsy because threads are it'll take some time for you to understand. So maybe tomorrow at the same time we'll meet. So tomorrow's agenda I will set it today. Like tomorrow after 11 o'clock you can join. At 11 o'clock you can join exactly, where we will be learning these topics of string, string buffer, string builder, and string tokenizer. It's just some 10 minutes of discussion. You'll be able to understand this. Yeah, I will post the recording, but your sir has told me that not to post it now because you will not attend the classes. People will start skipping. Maybe after few days, I will upload all these videos on the same YouTube channel. Maybe today I will try this and try to upload this, or yesterday's class, all that I'll upload. Yeah, keep you have the channel link with you, right? Only this class. Okay. If you want me to upload this class, I can definitely upload this class. No problem. Okay. I'll upload this class. So tomorrow's topic is this. Like I am enforcing this tomorrow. I'll be discussing string, string buffer, builder, tokenizer. I think this is not more than 20 minutes. So 20 minutes topic it is. So making a class mutable means string is immutable in nature, right? Means you cannot change once you create a string, or it has a string constant pool. So to avoid those disadvantages, the Java provides mutable classes for strings called a string builder, string tokenizer, these classes. So tomorrow I'll be discussing these classes. And after that, we will be discussing what are files or file handling. Okay. There is one remote file. Maybe you want to go read that file and see what are the things which are present in that file. And you need to write it into another file, or read it from the file and print it, or you have some data you want to write it into a file. Okay. If you want to do that, then like how to do it, we'll understand in tomorrow's class. Tomorrow class will be very important because file reading and writing is very important topic compared to like normal programming, because in your real-time projects, right? Say for example, this project you take, any project you take. If you go to SRC, just go to some of the project that he has created. Just go to any of the project and see there will be some files that you will definitely need to read from that. Okay, read from that file and then use that in the program. So that is what is the main activity for every product or every real-time Java projects. We need it. Okay, say in shopping, so you here there will be something called as some files which are there. Say I'll go to SRC. You can see this constants, right? In this constant, you have some constants, or there will be some files where you need to go and read those files. Maybe it is text file or it is some other file, but you need to read some data from the file. Okay. Like for example, today's attendance somebody gives me and asks me to store that in a real-time Java application. I want to read that Excel file, right? I should be able to read the Excel file. What are the data present in that? I should be able to store it in the database. So those kind of activity we will do tomorrow. Very important. Don't miss that session. Yeah, that's what I told you now. Multi-threading is the topic that we discussed now. Okay, so what is multi-threading is what we discussed till now. We are not there in the class, like how to create multiple threads and how to have one resource, right? You had that run method. Inside that you can write any logic. I did not write any logic. I wrote only for loop, right? So there you can write any logic and you can create any thread. Okay, all threads were started will go and occupy the run method. Okay. So like to be honest, in my project, we are using threads, but not the classes that you are learning here. Okay. That is something different. It's called as reactive programming. But okay, reactive. Okay, show me some problems in eBox. eBox problems are very simple. Maybe one. I'll just show the eBox problems. Multi-threading. I think I'm locked out. I don't know. I'm sorry. I'm not able to log in from morning. There's some technical difficulty from my side with eBox. I'm not sure what is the reason. And now it is working. Just a minute. Yeah, problems are simple, like how I told you the two ways, right? To extend the runnable interface and have class extended to thread class. So those kind of problems will be there. But there will be some theory part of it before you solve. That's it. The logic remains the same. I'll show you maybe one or two problems so that you'll get that confidence and you can solve it. Just give me a moment. Okay, so problems are like stall revenue, profit or loss. Okay, so I'll just go with some code and show you. Makes sense. So maybe first problem. How this problem looks is you have a class called as stall and you want to implement a runnable interface. I told you, right? There are two ways of creating thread class. One is extending thread class. Other one is implementing runnable interface. Correct. So they are saying to implement runnable interface. And what is that they're saying is these are the attributes, and there is one constructor, and there is a method called as run method. In run method, I was writing a for loop, but here they are saying you should write this formula, that is stall area into 150 rupees. So this is what you need to do. Okay. So like you have to create, if they are asking multiple threads to be created, you just see, okay, there are multiple stalls present, one stall, two stall, three stalls. There are three stalls. You want to find out what is the total revenue. To do that, means you are creating three threads, and every time you call a thread, you are supposed to do addition. That is what they mean. Okay. Okay. Let me show you how it is written code. Like the initially what you will do is you'll have a stall class and all these details you'll enter, and one constructor you will write, and there is a method called as like a run method. You know run method, right? I'm overriding run method, and in run method what I'm doing is stall cost is equal to stall area into 150. So what is stall cost? It is already attribute present here. The stall area is an attribute, stall cost is an attribute. So where you will get this, you will get it from the input. See, they are passing. This is the name of the stall, book stall. And what is this 25? You should see what is 25. 25 is the stall area. Okay. So you will get the stall area and you need to multiply it with 150. So every time your logic is 25 into 150. So next time you read the second input is 60, 60 into 150, right? You'll every time add it. Okay. In your main method, what is the code that you will write? You will read all the data from the user, split it and store it in a stall array. Okay. and you will iterate each and every one, like while loop you are using, you'll get one value, and then you're creating stall object and you're creating a thread object and you're using that stall. Now, what I did, I created demo object and used the demo inside this thread. You remember? So the same thing they are doing and they're calling run method. That's it. Total cost. Every time they get the cost, they are adding it to total cost and they are printing the total cost. Okay. Very simple. Maybe I'll share this code with you. You can go and try this out. Same implementing runnable interface is what we have done here. That's it. Implementing runnable interface. But the other will have different logics, maybe profit and loss. We'll see what is this problem, profit and loss. So this has an event class and hall booking class. Okay, they are saying, yeah, here also they are implementing runnable interface. Okay, implementing runnable interface. And the same logic, whatever you did, same thing you need to read. You have these attributes, they would give some logic, like here, they have given some formula. Write this formula in the run method. That's it. Every time you do this, you store it in a variable. Okay, so it is first problem is exactly same as second problem. If you know the first problem, second problem is very easy. Okay. You try solving this. In case the other problems, if you get doubt, you can come back to me. Okay. Very simple. You go and try it with the basic topics that I told you now, right? Using that, maybe this inter-thread communication will not be there. Only the basic